This video is on synthetic division of rational expressions. We use synthetic division in very special cases of dividing rationals. We need to have a linear binomial divisor. So linear means that there won't be any exponent greater than 1. So we're just going to have a plain x term for the first term, and the second term will only be a constant. A binomial means there are two terms. So you have to have something that looks like this to be able to use synthetic division. Long division is always our backup. We need to be able to do it because in most cases, that's what we would need to do. You'll see that synthetic division is really a nice shortcut. So to use synthetic division, we're going to start by making this sort of L shape. And we'll make it long. You do need to have your dividend in descending order with no holes. For instance, if there was no x squared term, you would need to put a 0 in its place. We're always going to take the opposite of our constant portion of our divisor. And so the opposite of -3 is +3. And that's going to go outside the L. Up top, you're going to have 2 rows here. We're going to fill in the first one with the opposite of the constant part of our divisor outside the L. And inside is going to be all of our coefficients in order, including the constant at the end. So our coefficients are 3, -2, +3, and -4. Now we need this space here because we will be filling in some numbers there. The first step in synthetic division is to bring down this first number. Whatever it is, you just write it below the L. All the math that's involved here is multiplying and adding. We take our divisor number out here and we multiply it times the 3 we brought down. 3 times 3 is 9. You put your answer here and you add down. This gives us 7. We again multiply by this 3 outside the L, and that gives us 21. Our answer goes in here and we add down. We multiply 24 times the 3 outside the L. We get 72 and we add down. So this seems sort of random, but now our degree of our answer is always going to be 1 less than the degree of the original dividend. So instead of starting with x to the third, we're going to begin copying our number coefficients here using x squared for the first term and +7 because it's a +7, plain x for the next term. And we're just counting down. The next one is +24. That's the constant. The last number is always the remainder. And so we add our remainder over our original divisor, which is x minus 3. Now I know this really feels like a trick. Someone very smart figured out that you can do this without the variables. I want you to take a look at the long division for this same exact problem. So I've written out all the long division steps and I want you to look for the similarities. You see this 9, 21, and 72? Here they are, 9, 21, and 72. And of course, the coefficients that we ended up with here, those are the answers that we ended up on top. We have to get the same answer. It's just a different way to arrive at the solution. And so there is math behind this. It's not a trick. It's just a way of shortening the whole thing, sort of collapsing all of this long work into something that's short. You do have to remember to make your degree 1 less than what you began with. So there's a few reminders here. Let me get this out of the way. Synthetic division only works when the divisor is linear. The divisor must have or be forced to have a leading coefficient of 1. And so we'll look at one of those in a couple of minutes where we have to force it. The quotient, the solution, has a degree 1 less than the dividend. So the degree is always 1 less than the highest exponent in the original problem. This requires descending order. Any holes need to be filled in with a 0. So if you have a term missing, it is vitally important that you put a 0 in its place. Let's try one. I'd like you to try this one, but I want to help you get started because this is an example of one that is not only not already in descending order, but there is also something missing. So I know that to write this in descending order, a to the third has to come first. The next would be a squared, but you notice there isn't an a squared term. This is where it's very important to fill in a 0 a squared. The next term in order would be a, and I have that one, so minus a is coming from here. And the final term would be a constant, which I also have, that's a +6. So this is my problem rewritten in descending order with the holes filled in. Now you're going to take it and set up your synthetic division. Remember, opposite of the constant part of the divisor. So a -2 is going to go outside the L, and all my coefficients will go inside, including that 0. Don't forget, when there's not a number, it's a 1, in this case, -1. All right. Begin by bringing down the first one, multiply it, add, multiply, add, multiply, add. Remember, this last position is the remainder, so in this case, there is no remainder. Since my degree was 3, I'm going to start with an a squared with this first coefficient of my answer. That means I have 1a squared minus 2a comes next, plus 3, and there is no remainder, which means this is my final solution. The next example that we're going to do is an example of what happens when we don't have a leading coefficient of 1 in our divisor. To take care of this, we're going to need to force it to be a 1. To do so, we'll have to divide by 5. And we have to do it in both places. That'll force this to be a 1, and this expression turns into x plus 6/5. It sounds complicated, but it's actually going to work out quite nicely in the end. We still have to take the opposite there. So we're going to use -6/5 as our number outside of our L. Our coefficients are 5, 11, 26, and another 26, all coming from our original problem. All right, so the first step, of course, is to bring down the first coefficient. And now we multiply, and you can use your calculator for this. I know it's scary when you see fractions, but your calculator can handle it. -6/5 times 5 turns out to be -6 because the 5's end up canceling. Add down, and I get 5 again. So when I multiply, the same thing happens. My 5's end up canceling. I get -6. Add down, and I have 20. When I multiply -6/5 times 20, I get -24. And when I add this column down, I get 2. So here's the trick. Because we divided out that 5, we have to take that into account for everything in my quotient, which means all except for the remainder is going to have to get divided by 5 again. Because the remainder is going over the original divisor, I don't have to worry about doing it to that portion of the quotient. So what should our first variable be? Well, since the original problem has an x to the third, we're going to start with x squared. And we reduce the fractions here. 5 over 5 is 1 x squared. The next term would be an x term, and 5 over 5 here is just 1x. And the next term would be a constant. 20 over 5 is 4. And we will add our remainder over the original divisor, 5x plus 6. All right, a little more complicated. You do have to remember to divide out again from the answer, whatever it is you divided out in the beginning. Let's look again at the long division and see how this compares. First, you can see that, of course, the answer is the same. You might find long division easier for these types of problems, and if you do, go for it. The long division or the synthetic division will work here. Notice that we still get these same numbers, the -6, the -6, the -24, and the remainder of 2. So this is all connected, and I know that some of the reasons why it works isn't quite clear, but the fact is that it does, and you just have to be careful about the steps. This next problem is for our honors students, or a challenge problem for students in the other classes. In this case, you'll notice that we have an imaginary number here, and this is really going to work the same way. So if you're in the regular class and the challenge problem is overwhelming to you, go ahead and fast forward on to the summary. For everyone else, let's set this up the same way we have everything. We use the opposite here outside the L, so -2i. We set up our coefficients, making sure to fill in holes. So we have a 3x to the fourth, but since there's no x to the third, I will put a 0 there. The x squared coefficient is -3. The x coefficient is 4, and the constant is 3. Go ahead and pause the video. Be very careful with your eyes now and try and complete this problem on your own. When you come back, you'll see the work and the answer. Okay, this was quite challenging, and I'm guessing that there were probably some small mistakes, but let's learn from them. You brought down the 3, and you get -6i when you multiply. So adding that is simple, but then when you multiply again, we get +12i squared, and I show in green here, I squared turned this into a -12. When you add, you get -15, and again multiplying gives us 30i. When we add here, they're not like terms, so I just put 4 plus 30i in parentheses to help me keep it separate. Now when you multiply, you have to distribute, and you get -8i minus 60i squared. Again, in green, I changed the I squared and made this a positive 60. When I add this down, the 60 combines with the 3, I have 63 minus 8i. So that was a little complicated. You have to be very careful when I is involved, but it can be done. We start with the degree 1 less than our dividend, so it was 3x to the third minus 6ix squared minus 15x plus, this is our constant, 4 plus 30i, plus the last box is the remainder over the divisor, which was x plus 2i. This was quite challenging. I hope you did well.